coincidence and you're wondering what's going on, now's your time to either run or grab a beer. I recommend grabbing a beer. So, if you're not aware, Bremerton's been invaded recently by a team of astronomers. So we're over in the Convention Center all week, and this is for something called LSST, which is the Large Synoptic Survey Telescope. This is a major world telescope that's being built down in Chile. It's hoping to operate starting in 2022, and it'll be one of the largest astronomical surveys ever conducted. So we have a team of international astronomers here working on it, talking about it, planning it out. And if you're wondering why Bremerton, well, I guess the last couple of meetings were Tucson, and Phoenix. If you're watching the news, it's definitely a lot nicer up here than down there. So it's good to be over here.
Big mac and cheese?
There's a local astronomy professor named Bob Abel who works at Kepler College, who's instrumental in getting the conference here. And he thought, well, instead of going down to Seattle, where it's crowded and expensive, let's come over to Bremerton. Great group of people, lots to do here. We've got a brand new convention center to use. So it's great to be here. I myself have actually lived here for about 2 years. And so, if you're wondering what an astronomer is doing living in Bremerton, well, I married an engineer who works in the shipyard, so there you go. For the rest of everyone else is visiting. So we got a couple speakers, there'll be 5 of us tonight, going for about 15 minutes each. And I'm going to kick it off and talk a bit about the Kepler Mission, which is up and running and has been for a couple of years. It kind of ties into LSST in terms of getting lots of data and lots of good astronomy. So I figured I'd kick it off going back a couple thousand years. I think is a good place to start. Kind of talking about the ancient Greeks, a lot of ancient philosophers out there. And it turns out that a lot of people back then, they weren't stupid. There were actually a lot of smart people. And they figured out a couple things that we kind of take for granted now. The first one, was there going to stand up here? Can't tell the speakers. Oh, perfect. And you can see me as well. Okay, perfect. Test. All right. That's true. I'm closer to the bar tap, so that is always a plus. All right, so it turns out that people even a couple thousand years ago figured out 2 main things that we take for granted today. And the first one is they looked up in the sky and they saw all these stars, right? Points of light. And a lot of them figured out, hey, all right, here's the sun, here are these stars. I bet that those stars out there are just our sun, but a lot farther away. Right? We take that for granted now that our sun is a star. But a lot of people figure that out. The other thing they figured out is that the Earth really does go around the sun. There's ancient writings going back 2000 BC where people said, hey, you know what? This whole Earth being the center of the universe thing doesn't really make sense. I think the sun is the center and we're revolving around that. So for a long time, people have known that the Earth is a planet going around the sun and that there's other stars out there and they're like our sun. But what they didn't know is that if planets like Earth were out there or not, were we the only habitable planet in the galaxy? Did the stars have other planets as well? I think it's really fascinating to think that we didn't know the answer to that question for sure until only 20 years ago, right? So as a species, we've been thinking about it for thousands of years. But only in 1995 did we detect the first actual solid planet going around another star. Interesting thing is that some of those first planets we found 20 years ago were nothing like we see in our own solar system. So they were the size of Jupiter, big, massive planets, like 11 times the diameter of Earth, many, many, many times more massive. And so they were these huge things like Jupiter, and instead of being far out away from the stars, they were extremely close in. So we call them hot Jupiters, because they're orbiting really, really, really close to their host star, and they're thousands of degrees hot. So again, nothing that we've seen in our own solar system. But we found these things because they were the easiest things to find. They were the big planets, the massive ones, which put our telescopes and look at the light. They exerted the biggest influence on their star, and so they were the easiest things to see. So we started to find a couple of planets, we found a couple more and a couple more, until 2000. 5 years after 1995, in the year 2000, we found our first, what's called transiting planet. So there's a lot of different ways to find a planet. The method that Kepler uses that I'll talk about tonight is called the transit method. So what you do is you stare at a bunch of stars and you look at their light. And for the most part, stars are relatively steady. They have a certain brightness and they hold that pretty constantly as you look at them. But if you look at a bunch of them and you stare for a while, what you'll notice is that they'll be at the same brightness, and then you'll see a dip for a couple hours. It'll dim, and it'll go back to how it was, and then a little while later, it'll dim again. And a little while later, it'll dim again. And that regular dimming that you see is because there's a planet going around that star and it's periodically passing in front of it as we look at it from Earth. So there's all sorts of planets out there. Some are going in this orbit, some are in this orbit, but we see the one particularly, we see Earth right between us and that host star. So it blocks out some light. So this is a great way to detect planets. Now, the neat thing about Kepler is that it's the first mission that's launched that can actually find an Earth analog, a planet like Earth, at the same distance from its host star and the same size. You know, we found plenty of big planets, but we hadn't found many small planets like Earth. So the Kepler mission launched in 2009, and it's a space-based telescope. So most people who here, raise your hand if you've heard of the Hubble telescope. I think maybe a few people, I see a few hands there, yeah, Hubble. Everyone knows Hubble, right? It's been up there for 20 years as well, right? It's been a long time, it's kind of a household name. So the Kepler telescope is very similar to Hubble. It's a telescope in space. It's a little smaller than Kepler. Kepler is about 3 feet in diameter telescope, so it's not really the biggest one out there. But it's got two things that make it really unique from Hubble. The first one is that it kind of has a dedicated mission. So Hubble is used to doing lots of different science. Astronomers use Hubble to look at galaxies, to look at stars, to look at planets, look at things like Jupiter and our own solar system. It has all sorts of different purposes. Kepler is a dedicated mission. Kepler is just trying to answer the question, how common are planets like Earth out there in our galaxy? The second thing that's different is that Hubble is actually really close to us. It orbits the Earth really closely. So about every 45 minutes, it's going around us, which is actually a lot closer than most communication satellites we have out there. And that's why we've been able to go up and service Hubble with the space shuttle and actually be able to go up to it and fix it over these years and improve it. Kepler, in contrast, it's not orbiting Earth, it's actually orbiting the Sun. So it's just kind of lagging behind us and following behind us as we orbit the Sun. It's orbiting the Sun as well. This is because if you're close to Earth, there's a lot of light, a lot of interference, a lot of noise going on. And so you really want to be far away from the Earth in the dead of space where it's nice and calm. So Kepler launched in 2009. And what it did is it just stared at one patch of the sky for over 4 years, right? Things like Hubble, other telescopes, they move around. Kepler just sat there like this and didn't blink, just staring at the stars for over 4 years. And that's because if you're looking for a planet like Earth around a star like our Sun, can't hear me still? Oh, okay. So if you're looking for a planet like Earth around a star like our Sun, and you're sitting there and you're waiting for it to pass in front once a year, well, guess what? You've got to wait a couple of years to see it go by a couple times. I mean, you stare and you see nothing for 364 days. And on that 365th day, you see that star dim a little bit, boom, and you have to wait a whole another year to see it happen again. And you want to see it happen a couple times to make sure that you're actually seeing the planet. So Kepler sat there, stared for over 4 years, and we have all the data in hand. We've begun to analyze it. And the really cool thing, again, we didn't know of any planets for thousands of years. We just started finding the first handful of them 20 years ago. And with Kepler now, we know of over 1,000 planets that we've confirmed and over 5,000 possible candidate planets. So we're literally now talking about thousands of planets we found around stars other than our own sun, which I think is really exciting, the fact that we found them. And we found all types. We found those hot Jupiters that are close in. We found things that are really interesting, things that are between the size of the Earth and Neptune. So here we are on the Earth. Neptune is about 4 times the size of Earth. We found all these planets in between us, twice the size of Earth, 60% bigger, 3 times. And these planets, we have no analog in the solar system. We found solar systems that are completely different from our own. All of the planets are closer to their stars than we have Mercury in our own solar system. We found solar systems that have up to 7 planets, very close to the 8 in ours as well. So we're finding all sorts of cool things. Who here has heard of some movie called Star Wars or something like that? Yeah. So remember Luke standing in the desert in Tatooine, he looks into the sunset and he sees not 1 but 2 stars on the horizon, a double star system. We found just the 10th planet like that very recently. So we have actually found planets that are around binary stars. So the 2 stars orbiting each other, and you have a planet farther out. So if you were to stand on that planet, very much like Luke Skywalker, you would see the double sunset rising in the distance, which is really neat. The cool thing of Kepler, again, its main mission is to find out how common is Earth. And so the neat thing is we've been finding planets closer and closer to the size of Earth. A year ago, we announced a planet called Kepler 186f. Not a very imaginative name, but it helps to keep track of, just giving them numbers. So 186f, we looked at it, and it turned out it was only 10% bigger than the Earth, so very close to our size. This means that it's very, very likely to be rocky and have a solid surface we can stand on. just like the Earth. The really neat thing is the amount of light it receives in comparison to the Earth was something like 50%. So it's actually cooler than the Earth. Most of the planets we found are hotter. This one's probably actually cooler. If it has liquid water, which it has a chance for, that might have some big ice caps on it. You know, we can't really be sure exactly what it looks like, but it's a very good possibility of being habitable in the terms that we think of it as having the right temperature to have liquid water on your surface. The only thing about that planet is it orbited a star very different from our own. It happens to be called an M-dwarf, so it's like half the size of our own star. And that's not bad, we just don't know too much about those stars and how they affect the planets around them. So just about a month and a half ago, we announced a new planet called Kepler 452b, and this one's quite exciting. It was about 60% bigger than Earth, so it's got a bit more mass to it, but it has about a 50% chance of being rocky. And this one was around a star very much like our sun, nearly a twin. In fact, its orbital period was 385 days. Ours is 365. So we've been getting closer and closer. We've been finding more planets very similar to Earth, and we're still going through the data and finding more of them. The really neat takeaway is that before Kepler launched, we really didn't know if planets like Earth, if there were any left that are like us, or if we were 1 in a million, or 1 in 1,000, you know, even 1 in 100. And the really neat thing that thanks to Kepler we're finding all these candidates similar to Earth is that we know that we're at least 1 in 10, and probably more like something like 1 in 4. So if you go out in the night sky and you look at the stars, around every fourth star, there's probably a planet very similar to the size of Earth, at the right distance from that star, where it's the right temperature to have liquid water on its surface. That's all we can say right now, but I think that's just fascinating that there's, you know, at least 100 billion stars in our galaxy, which means that there's probably tens of billions of planets similar to Earth in its size and temperature out there. So that's the thing I want to share with everybody. I think it's just fascinating. So the odds of other civilizations out there, you know, just got sky high. Who knows how often people like us arise, but in terms of the planets out there, they're quite common. So I think it's exciting.